Hello, my name is Raj, and this is the neural network music genre classifier I made for my final project for AP Calculus BC. I simply just wanted to show it out. So the first thing I'm going to do is actually show it. This is what I did in my class. I used Google Colab, which is really good for machine learning. Just give it a second. I'm going to search up a song. Guess Millie Jean. I like this song. I usually use Michael Jackson because it just works pretty well. So this is a part of my code book where I actually train the model. I'll go a bit more in depth later on. I'll just show you the actual model first. So we can see everything ran fine. I'll go more into detail a bit more on what this is, but as we can see, Michael Jackson's Billie Jean is very similar to reggae. In fact, it's 100% similar. That's what the model predicted. So, yeah. So, continuing on, why did I choose this? A neural network is really prominent in the field of data science, and I'm going to major in data science at my college this coming semester since I graduated. And I'm trying to get into the AI field, so I feel like doing this, I felt like doing this for my final project would be pretty noble. And I wanted a project with calculus that could also apply to my major, which is this a neural network. There's a lot of math required. And the reason why I chose music classification is that it felt a bit more interesting and it was a bit more fun, you could say, especially to an audience, than the very hello world like MNIST database number classification. People also usually do that from scratch without TensorFlow or Keras, and that'll make it very coding heavy. Which for me, I just wanted to create a simple project that I could show would be fun, and that I could demo. And doing such a coding heavy project would not really be that good, personally. So the way I learned how to do it and how I did it is around AP exam season or a bit before. I just started by watching. I had my final project and it's like scriptures and whatnot. I had it before the AP exam season, so I was just watching a few videos and getting a few mental notes of how neural network works in my mind. And then after the exams, I just got to Google Colab. I used TensorFlow, Keras. I tried using some other libraries like Librosa. I had to learn Matplotlib a little bit. And yeah, trial and error. The biggest learning came from debugging it. So I would write a cell, run it, it would not work, and then I'd fix it. And repeat until it finally worked. But some things just did not work. I had to get one of my friends who's studying computer science to help with my code. So how does a neural network work? What is it? A neural network is a model that learns patterns from examples instead of following rigid rules. It is made of layers of neurons. So it basically tells you how similar something is through neurons. I would like to give an example. let's say baseball. Imagine there's a pitcher throwing you a ball and you have the bat and you want to hit a home run or just hit the ball or whatever. How do you know where to hit it? Our brains automatically analyze the ball and whatnot. You have to analyze the pitcher, what hand he's throwing from, how fast the ball's going, if it has spin, if it's going left of you, right of you, up, down, if it's even going to you at all. There's a bunch of other stuff. And also, like, how strong you are, how fast your hands can move. Our brains automatically do this. And so, neural networks, it artificially replicates that. What I just gave you could be theorized as numerical inputs. So, how fast the ball is, velocity, the spin of it, you can dictate in the angular velocity, like, and the pitcher, if he uses left or right handed, that's a Boolean value. So, and it changes every time the pitcher throws a ball. So, what a neural network does is imagine you had a training where a pitcher throws you 1,000 balls, and so your brain automatically just tells you. So if the ball's going like this speed, for example, you hit it more hard because it has to go further, or this and that. That's what a neural network is, and that's what's training it. Training basically means you're adjusting each weight so that the predictions become more accurate. And I can show you this. This part is where I actually train the model. So pandas, numpy, this and that. What mine is, I take the GTZan dataset from Kaggle. It's, I think, 1,000 songs, and it gives 58 features for each of those songs. So then, basically, you run that through the model each 1,000 times, and each time it changes its neuron value so that it basically just changed a bunch of numbers. So if, I don't know, the tempo is this high, then it's more acclimated to reggae or pop rather than blues or something like that. And each cycle is called an epoch, that's what this is, and each time the loss goes down, so it's more accurate as it goes. Here's each of the features. This is the numerical value. So once I train the model, I take in like a YouTube, what I showed you, I take in a YouTube link, and then I put it into this, and it turns it into numerical data, these 20 features, through Librosa. It's a Python library. Tempo, stuff like that, spectral roll-off, and then it just runs it through the model and gives me an answer. That's what I did here. So yeah, I taken the GTZan, got it from Kaggle. So going over the architecture, my model inputs 58 audio features. So like tempo, what I said before, and then it has these numbers are arbitrary: 256, 228, 128, and 64 neurons, and then 10 as the output layer. These numbers, they're just arbitrary. They don't really mean anything. They can be whatever, but it's usually you go less and less neurons so that it doesn't overcomplicate the model. And then it just goes from here to here to here to here to here, and it creates an answer for each of these. It creates like a value I showed on the graph for each of these themes, genres. So blues, and we saw with Billie Jean, it's 1.0 probability that it's reggae. So now I need to go over the math, and I think I'll actually... So, gradient descent. The network learns by minimizing a loss function, so the less loss there is, the more accurate it is. That's what loss is. So, you take in a weight as weight old, as seen as the equation, and then you subtract the learning rate times the derivative of the loss with respect to every weight. And I'll I'll explain what this is. But what eta is in this case, this Greek letter, it's the learning rate. If it's too high, you overshoot and your model just does not become accurate. And if it's too low, then it just takes forever to train the model and whatnot. And then you times that by each loss and each weight. So, and you can't do that without backpropagation. So what this really is you're taking the derivative loss with each weight. So it's the first loss with the activation function, then the next one, then the next one, then the next one, then the next one. The reason why you need a partial derivative, which I haven't even learned, is because there's so many weights. There's a bunch of weights. And you need to take the derivative with respect to each of those weights. So then it comes back into this. And the reason why you subtract it is gradient descent tells you like which is the steepest curve. So in the 58 dimensional space, I don't know. If it's this way, then you go the exact other way. So it reduces the loss. And then, so what each neuron is, it's a function. And you put in some sort of value, and then it just tells you what to multiply. So when you give it the input values, like a new song, like Billie Jean, each neuron just calculates, like, so if the tempo is this high, then this neuron will be activated to this probability, like, I don't know, 0.64. And I put this in for my project since it connects to calculus. This is called the sigmoid function. This sigma of x, and this is a graph, the top one, that's the sigmoid. That's used to non-linearize the data, so it doesn't become super, like, one-dimensional, you could say. It doesn't become simple. And I haven't seen this graph really outside of machine learning, but if you've taken a statistics class, you've definitely seen this bottom graph, which is its derivative. This is a normal distribution curve. I didn't really use this in my model since I use ReLU. ReLU is a super simple function, fx equals max of 0 to x. It's super linear. It's not like curvaceous like the sigmoid is. And then I modeled my training loss over 100 epochs. I can show you this somewhere here. This is what this is. And it follows an exponential decay curve. This is the curve when you interpolate it. And basically what it's saying is that each epoch, it's improving at this rate before E, and this plus 0.0938, that's the irreducible floor, so it can't get any more accurate than that. So let's say epoch 10, the model was improving at around 0.0619 per epoch, and then it approached the floor. So here are my results. The training accuracy was 98.5%, and the test accuracy was 75.5%. Basically, there's in the GCCN genre, like, part, it has a training part, and then it has a test part. So basically, when I trained it, it showed overfitting, meaning that it learned the training set better, so that when it got new songs, it can't actually perform. It's just too used to its like training data. So when I actually got data, it just couldn't do anything. And I'll never give you up. The model predicted disco with 76.7% confidence. That was like my basic thing. So I'm gonna go over a bit more on what each of these things are. So this is loading the model. This is like training it, all training. This is where I deploy Keras, and then these are the layers, and then we can see the parameters are 56,000. It's a lot. So there's a reason why people do this on computers now. You could actually do this in olden times, but ever since CPUs, you could just do this a lot better because 56,000 parameters is just too high for a human being. And if you want to do this on paper, which you can, it'll just take a long time and you likely won't be able to. This is me training it. We can see the epochs. The loss goes down and down and down and down. These are my features as I showed you before. This is each feature and what they mean. This is the exponential regression I made for the model. This is interpolating it, and we get this function. And then here's my demo. This is me loading the YouTube URL. This is Librosa. This is it turning into a waveform part. This is the signals. You don't really need to do this, but it just shows you that it actually transferred into numerical inputs. Here I put like the importance of each audio feature, so we can see that this is more important, this is that important, whatever. And this is all happening in 58 dimensions, so I can't tell you any of this because it's all computerized. This is actually going through it. This is the diagram I showed earlier of the activations. And this is the output. We see that Billie Jean is reggae. And these are just graphs I made. So this is a thing I showed you before. Same graph. And don't worry about that. That's just making sure my thing works. So yeah. That's basically it. And I'll link in the description like everything I use. I can show you guys my paper. I'll show you guys the notebook. Yeah, and then you guys can review it. I'll put my GitHub as well down there. I put in GitHub, this and that. So yeah.